Did you know that a single small measurement error in custom furniture manufacturing can cost a company hundreds of millions of Vietnamese dong every year? In this video, we'll walk through a real-world operations investigation of Noi That Hong Khoi, a Vietnamese custom furniture manufacturer, carried out by a student team from an operations management course at the National Economics University through direct observation at the factory. From first-hand factory observations to concrete financial figures, this is a complete picture of how operations management tools can be applied to improve productivity, quality, and workplace safety. Before diving into the analysis, the research team used a weighted decision matrix to select the most suitable factory, scoring candidates on criteria such as accessibility, management cooperation, process complexity, operational visibility, and learning value. Among the factories considered, Noi That Hong Khoi scored highest, thanks to strong cooperation for management, diverse manufacturing processes, and rich opportunities for observation. The company is a Vietnamese furniture manufacturer specializing in customized products for both residential and commercial clients, wardrobes, kitchen cabinets, office furniture, and more. It operates under an engineer-to-order model, meaning every project requires its own measurement, design, and installation work. This model provides flexibility, but also creates real operational challenges. And that's exactly what this report sets out to uncover. The next section of the report focuses on production quality. The factory investigation uncovered a string of issues: dimensional errors, surface scratches, rework, on-site installation adjustments, and delivery delays. Of these, measurement error was identified as the most serious root cause, because every product is built to a specific customer's measurements. Even a small mistake can cascade into a string of downstream problems. To trace these issues back to their roots, the team built 3 Ishikawa diagrams, analyzing causes across 6 categories: manpower, machine, method, material, measurement, and environment. The findings: measurement-related issues are the single biggest cause category, driving rework and delivery delays. Method-related factors rank second: weak production visibility and delayed quality inspections. Next come material factors, such as hardware shortages, material weighting, and transport damage. Manpower factors involve skill variation and communication gaps between departments. Machine issues play a secondary role, while environmental factors, like with dust and cramped workspaces, affect both product quality and worker performance. From this analysis, the report highlights 3 root causes that demand immediate attention: inadequate measurement verification, insufficient control over production scheduling, and quality inspections that happen far too late in the process. So how does Hong Khoi's current production system actually run? The process starts when a customer submits an inquiry, followed by consultation, on-site measurement, design and quotation, manufacturing, quality inspection, and finally delivery, installation, and handover. On-the-ground observation revealed that the real process is far more complex than it first appears, full of feedback loops, approval stages, waiting periods, and recurring rework, all of which stretch out project timelines and erode overall efficiency. The report identifies 3 major bottlenecks. The first is site measurement and design approval, since no manufacturing can begin until this stage is complete. The second is the finishing stage, which depends heavily on worker skill rather than machine assistance. The third is on-site installation, where external factors like site conditions can cause delays. Applying lean manufacturing principles, the team also identified multiple forms of waste: waiting for customer approvals or materials, transportation, as materials are moved repeatedly around the workshop, motion from workers walking between stations, excess inventory, and, notably, defects. Overall, the current system can be described as functional but inefficient. Next, the report takes a closer look at the current standard operating procedure, or SOP, used at the factory. It consists of 6 stages: customer consultation, site measurement, design and quotation, production planning, manufacturing and assembly, and final acceptance. While this SOP supports customization well, It has three major weaknesses. Measurements are taken only once and rarely re-verified. Quality inspections happen too late, typically after most of the manufacturing work is already done, and production visibility is limited, with progress information not shared in real time. On the safety side, the team identified several notable hazards: airborne wood dust, risks from cutting machines, manual handling of heavy materials, cramped workspaces, and noise from equipment. The report includes a detailed safety hazard assessment table, in which 3 risks are rated high: heavy manual material handling, contact injuries from cutting machines, and wood dust inhalation. Importantly, the report stresses that workplace safety shouldn't be treated as a mere compliance checkbox. It's an integral part of operational performance, since a safe, organized environment helps workers stay focused, which in turn improves both quality and productivity. Based on all these findings, the research team proposed a redesigned SOP centered on preventive controls rather than fixing problems after they occur. The new SOP introduces 5 key improvements. First, a mandatory measurement verification step before design work begins. Second, material verification before production release to avoid shortages mid-process. Third, a pre-cut quality check to catch defects early. Fourth, periodic quality inspections during assembly and finishing. And fifth, an installation quality check before final handover to the customer. These changes are expected to deliver clear improvements. According to the report's performance comparison table, cycle time could drop by 15 to 20%, labor hours by 10 to 15%, and the defect rate could fall from roughly 5 to 8% to below 3%, a 40 to 50% reduction. Meanwhile, operating costs could decrease by 15 to 20%, production capacity could rise by 10 to 15%, and overall productivity could increase by about 15%. More importantly, every single improvement is directly tied to a root cause identified earlier: measurement, quality, or safety, which means these recommendations aren't just operationally sound, they're grounded in solid evidence from the investigation. And here's the part every manager cares about most: the financial picture. The report estimates that current operational problems are costing the company roughly 600 million VND per year. Breaking that down, rework accounts for 200 million, delivery delays 100 million, material waiting 100 million, lost productivity 150 million, and safety-related inefficiencies about 50 million VND. To fix this, implementing the new SOP is estimated to cost around 105 million VND, covering employee training, 5S workplace organization, a quality control system, inventory management improvements, and a preventive maintenance program. The expected annual benefit? Around 600 million VND, from reduced rework, fewer delivery delays, material savings, and improved safety performance. Plugging these numbers into the ROI formula produces a striking result: a 471% return on investment, with a payback period of just about 2 months. That figure far exceeds typical investment thresholds in manufacturing. Proof that this operational improvement shouldn't be viewed as a cost, but as an investment with an extraordinarily high return. To sum up, the investigation at Noi that Hong Koi found a company with strong customization capability and a diverse customer base, but one constrained by measurement errors, material waiting, late quality inspections, limited production visibility, and workplace safety risks. Based on this, the team puts forward 5 concrete recommendations for management. First, prioritize a formal measurement verification system, since this is the single biggest root cause. Second, introduce pre-cut quality checks and intermediate inspection points throughout production. Third, build a visual production management system to improve cross-department communication and coordination. Fourth, strengthen safety measures, covering workplace organization, dust control, and personal protective equipment compliance. And fifth, establish a performance measurement system to continuously track defect rates, productivity, lead time, and customer satisfaction. This report is a clear demonstration of how operations management tools, from Ishikawa diagrams and lean analysis to safety assessment and financial evaluation, can help a small Vietnamese manufacturer pinpoint the right problems and design improvements that are both practical and remarkably profitable. Thanks for watching.